So welcome everybody, and yeah, I'm very happy to do this first Lynx TEDx presentation, which is opened not only for our colleagues but all the partners and customers. So special thanks for them for joining, and hope you will like it. So today there will be a special day. This is the DWH day, or data warehousing day, where we will speak about data warehouses, data lakes, and data lake houses. We will have an external presenter. He's Bram, so he will join from Databricks and will show us the newest technology. And I will speak a little bit about the data warehousing, the basic concept, and so on. So maybe we can go to the context part. So yeah, there will be an introduction to the data warehouses and data marts, and then we can see the types and goals and basic terminology. And after, as I mentioned, Bram will speak about the disadvantages of data warehouses and introduction to data lakes and the data lake house concept. And after, we will do a summary and a question and answer session. Okay, so before starting, then it would be nice if you could check this QR code with your phone. If you are not following this event in your phone, maybe I can also share the link. And then we could make a quick voting that what is your background. And in this case, I can a little bit adjust the topics, or maybe explaining some part more detailed. So you can see a link, and then I'm just starting the poll, which is on this link. I also can share the link itself with you. Okay. So you can vote, and I will try to share the results at the other hand. Okay, so I see the most popular part is ETL and SQL meaning, and also we have some expertise. Does that one? Sorry, my Siri just turned on. Okay, that's thank you very much for your answers. You can still vote, but okay. So then we can go, and then I will try to explain those parts, which maybe not. So if you are a beginner or just get to know the data warehouses, then you can learn here the basic terms and concept, and also what to focus when you be creating a data warehouse or have a data warehouse project. If you are a user or manager, then yeah, I will just summarize the steps of building a successful data warehouse. If you're a data warehouse professional, most probably the interesting part will be that showing that what a data scientist needs for a data warehouse. So what are those specialties? And it can be interesting for everybody to check these non-changing rules of data warehousing. So this is about this common knowledge. The second part will be the same for everybody, so catching up with the latest technology and methodologies. Okay, so this first part, maybe we can start, and then we can see that how is a typical data warehouse projects look like, or how is it coming. So first, we just have a few data sources that we can see on the left side. Basically, yeah, nothing. And then after, maybe within the organization or within the cooperation, some of these units or departments deciding to make some data marts, or at least some own databases, and then they can make some reports from this case. They are using several manual data sources and some data from their other systems, like for example POS data, or in a case of a telco, like CDR data, or this kind of source data. And also in some cases they are just using some other Excel files which somebody exported a few years ago. And then it can work for a smaller corporation, a smaller enterprise, but not for a bigger one. And then usually it goes until the CEO asks some easy questions, which nobody can answer usually, like what is the cost of a 10-minute call, or what is the profit? And then if you ask these questions that as a CEO, then you will find a lot of questions coming from your colleagues, like if it's before tax or after, or in the case of the 10-minute call cost, are the analysts included who are just doing this report now or not, and so on. And then there are many questions which is very hard to answer if you don't have some integrated single source of truth. So for this reason, usually people just do a kind of data warehouse project, and if the data warehouse is very good, then you can get your answer, and you can get your answer in a very accurate way. There will be also the definition of this revenue, or what does it mean exactly, how is it calculated, and what does it contain, and what does it not contain. So in this case, we can think that we are ready, but usually that the answer is satisfying, then it's followed by even more questions. So this kind of results is followed by a lot of other questions which should be answered. And also that if one time you created a data warehouse, and then we will see that a bit later that how difficult to do it, then you don't really want to make modifications. So that's why after a while, again, this kind of manual data warehouses and manual these systems appears, and there will be a bit chaotic situation again. So if you check a DWH guy, they will continuously ask that don't touch it because it's working now. But if you are adding one more source, maybe it will not work. But of course, the different head of the departments and the higher managers, they will continuously ask for some modifications. Like, and sometimes they even cross with each others. So usually everybody has some anger on the direction of the DWH experts, and also a little bit on the direction for each others. And then everybody starts to do again their own system. And then after maybe all of these requests somehow harmonized and also somehow developed, so we get again a very nice data warehouse, which we will check soon that what is it exactly, or actually what a data warehouse is. So don't worry if you don't know it now. But then after, we can just realize that, okay, now we have new challenges, now we have new input data. We want to use some kind of real-time video pictures. We want to use the SDK data of the users. So maybe the user has some kind of application. It's tracking where are they moving, and also what they are using in their phone, or what kind of apps they are using, and so on. We get clickstream data from websites, and we also get a lot of other data from these different social media streams. We are want to use or read blogs and web pages and maybe Reddit and get pictures. And of course, the pictures is always very hard to recognize. This is this well-known puppet or muffin questionnaire. Okay, but then we have a lot of new inputs, and then we also have some kind of new requirements which was not there before. Like we want to give some real-time answers. We want to give some real-time, or we want to do some real-time actions, so real-time discount for the customer for making sure that they will do the purchase if it's necessary. So for this, that we need very different technology, and that will be the second part of this presentation. So from 4 to 5 p.m. Singapore. But for that, and also that is so that is scalability as a new requirement, and also it should be cheap and secure. In this secure, it's also like redundant, so that we should make sure that the data is not be lost. Okay, so then now we can check that what a data warehouse is. So that is a very old knowledge. I mean, it's coming from the 2000s. And then maybe this is one of the best definitions. So the data warehouse is a subject-oriented, integrated, non-volatile, time-variant collection of data in support of management's decision-making process. So, yeah, what does it mean? It's a good question. So the data warehouse should have some kind of goal. So you need a strategy when you are building a data warehouse, because that will reflect on your corporate that how it will work. And then it's somehow, yeah, and then it should support all of this necessary report, all of the necessary decision-making process that you have nowadays, and also which you face in the future. So this is one part which is definition try to explain. Okay, so usually it's coming from some operational systems. So your source data is like, for example, a POS data, a CDR data. So some CDR which is coming from the cell towers in case of a telco and contains that if the customer had a call, who they called, how long was the call, and a lot of this quality of service data and timestamp and so on. So it's come from just the towers. Also, it's the same for the data, but just different columns. It can be a POS data. So for example, if you do some kind of purchase, or in case of a bank, then it can be data from the ATMs when you check your balance by your card, and a lot of others. So these are these operational systems or operative systems. And then in the data warehouse, we are trying to group these data sources in another way. So it's a subject-oriented way. And then, for example, we can mention, okay, these are the customer data or customer-related tables. And other set of tables is like the HR-related tables or the sales-related tables or the data usage-related tables, and so on. So this means that this is a subject-oriented collection of data. It's also integrated because we have a lot of different sources, but we want to do some or want to make some business decisions which considering all of these different data sources. So that's why it's integrated. We have to analyze the data together. It also contains a long-term history. So why these operative systems or transactional systems usually just keep the data from maybe 60 to 90 days. Like in a data warehouse, you can see the data from 10 years plus, or at least maybe 5 or some longer time period. And then also you can restore all the earlier version. So this means this non-volatile part in the definition at least. Okay, so it's also important that it's transformed into sources. It make them clean. For example, drop-dead applications or handling that application, handling all the different kind of IDs from the different kind of systems or unifying them, make some kind of aggregation if it's necessary, and so on. And it provides access to the data. So it creates reports or maybe just provide some access to different reports. And then of course, it means that we had to handle a lot of grants and others. So there are several user groups, there are several data reports that a certain user group can see, and so on. But I will speak a little bit later about these parts. It's also should be management driven, so it's support all analytical and decision-making processes of the company. And this should be some kind of single source of truth within the organization, because it means then everybody uses this data source, and then also these definitions which defined by the data warehouse. Usually, so some people just defining this central layer as a data warehouse, but now I'm considering almost everything. So the staging area and also the report preparation layer and all the data marts, which we will speak about soon. So the next topic is just like 3 examples for data warehouses. Don't start to read this slide. It's only can be made a data scientist because it doesn't have any pictures like if a business analyst made, so it's less easy to understand, but it's also break the rules. So it's also a data warehouse engineering doesn't make, because I have to move the subtitle here. But anyway, this is showing 3 different use cases. So one is this bank core data warehouse, which is of course a very robust, very conservative data warehouse. It's also we can check a kind of like web shop, maybe not the Amazon, but some smaller one. And we also can see that, okay, what is a quick telco data mart if we want to do a POC. So there are several these things that we can consider, like what is the business usage. So that's we will have to start the analysis with. Like in case of a bank, we should support the daily operation with dashboard reports, which are necessary. Also creating some important reports for the regulators, because otherwise they will penalize us. And also support a lot of analytical use cases like these credit scoring models and so on. And then there are maybe around 500 plus different goals that it should support. This kind of web shop, or this imaginary web shop data warehouse, it's like supports the daily operations, so make some reports. It also has some real-time recommendations, so that we can check these Lambda architecture, where there are 2 layers. One is just giving a fast response, and the other is this classical data warehouse, which can answer for the, or which can build up these models or get this kind of bigger dependencies between the customer's acts and this their future acts. And then it also can do real-time, give some real-time recommendations. So just show something to the customer to buy or give some discounts. And it also should support a lot of analytical use cases like pricing and so on. While a quick telco DM is also just built for a concrete use case, like building a churn model or building some cross-sell model or anything like this. It's also, most of the cases, built on top of an existing data warehouse. In some cases, it's for raw data. We will check an example for that. And it supports some related reports, but just a very few. So this kind of timeline is like 10-year plus, or 10 years in a case of a data warehouse in a bank. It's like mid 3 to 5 years in this web shop, and then 2-3 years. This accuracy and consistency, of course, is very critical for the bank. So there are several aspects which are very different, and it always depends on the use case. So this design of a data warehouse is determined by its goal and users. So we always have to find out that's who will, or who are they. Also, maybe this just worth to check that what are these kind of points here. Like there are different environments. So if you are making a data warehouse, if it's like in a banking data warehouse, you usually have a development, 1 or 2 test environment where you can test your developments in real data or nearly real data. There are 1 or 2 integration developments when you can test everything together. And of course, you have the productional one, but the productional one is really just secured and almost nobody can modify it. So you have a lot of UAT test or user acceptance test and this and deployment procedures. In case of a web shop, it's less critical, but still that is. So usually you have just 3 to 5 environments. So usually just DVP test and prod. And in this quick telco DM example, we usually have 1 or 2. So sometimes the production and the development even the same. And sometimes we have separated the development and the production environment. So there are these sources, like usually these banking data warehouses, they are just using mainly structured sources, like by the web shops, they have a lot of other, and also they are changing very fast. You can also check the freshness of the data warehouse and the response time, that how fast is it, and also the level of automation. And also we can speak about these user groups and grants. So for example, in a bank, of course, there are infinite number of user groups. The data is really sensitive. All of the reports that you can check, or the cubes or any kind of queries, it's almost row level granted. So you can exactly only see those data that you should see. In case of the web shops, it's not very strict, but still there are many sensitive data that you make sure that is encrypted for given users. And then also for a quick telco, it's some anonymization is necessary, but then it's less bad. In case of the service level agreement and redundancy and security, so of course in a bank's data warehouse should be very secure. So I was even just a telco's data warehouse one time, but it was like if you go to an airplane, so they check you if you have any pen drive or anything like that. So, and you only can go if you don't have anything like, and when you go out from the data warehouse, then they, again, the security guys check you if you moved something. And also a lot of cameras checking you continuously. So also they are expecting 99 point and a few 9% of service level agreement. I mean, this kind of service or readiness. And also they have a lot of backup processes, at least 2 in different locations. So you are not losing data. And in a web shop, it's a little bit less serious, but also quite serious. And with quick telco DM, you don't have to spend too much money for that. And of course, the sizing and running time, it's very different because a bank, as it was very hard to develop all of these processes, which are finally accepted. They have thousands of tables and so on. So usually the architecture is also quite old because they don't want to refresh it. So that part so for this reason, they are really conservative. So also the technology is kind of old. So for this reason, it's many times it's really a hard thing to push the daily run within 24 hours. Why these kind of web shops are usually cloud native, and then for this reason, but also Bram will show us some examples, everything is much faster and you need to do much less procedures and runs or this kind of loaded jobs or data load, and it's also not an issue of a POC data warehouse. And one more thing, this is the metadata we will speak about. So the metadata is the data of the data or data about the data. For example, the definition of the different terms which are used in our data warehouses. And of course, in case of a bank, it's critical because then everybody should understand the same thing under revenue or same thing under default for a certain use case. So that is critical that everything should be defined. Also, all of the data sources or all of the data tables should have a responsible person who you can ask if there are some errors or suspicious data. In case of a web shop, it's less important, and in case of a quick telco DM, it's even less important. But of course, at least an Excel is useful, which contains all the data in some or all the columns and some definitions. But it's usually like just this. Why here is you can imagine a Wikipedia page where everything is defined and everything is linked. Okay, so that we can go on the next step, that what is important in case of a data warehouse and how we can make a successful data warehouse project. So on this picture, I'm not sure that how many of you can recognize it, but this is an Oracle data warehouse builder or OVB, or Oracle Warehouse Builder. And then this basically, so these are the tables, and then these are the connection between the tables. So how you are joining the tables and how you are mapping the tables, different variables to these new tables, variables, and so on. But then the main part here, that every of these tables, like which are here, are also have a kind of logical design, which contains all of the variable names in an understandable way, and also these what are the keys of the table and so on. But let's go back to the beginning, and after we will come back to this picture. So the logical design of a data warehouse should contain all the business term and should reflect all for the future and current use cases of the data warehouse. And then usually a successful data warehouse project starting with these documentations. So comprehensive requirement analysis and harmonization, which check all the units and make some common definitions of the terms that they are both using. Also, it's very important that you should show a sample report from the very beginnings. So they will know that what they can expect. They can also give you some feedback. The report can be like an Excel report. It can be an OLAP cube. It can be some HTML access. It can be a dashboard. So it's under everything. But then you can make a very basic design and what data they would like to analyze together and so on. And also, you can speak with the data scientist or any other kind of units and finding out that what they need for analyzing the data. And then, yeah, so all the definitions should be there. And then you should make a kind of Wikipedia-like logical design. So where you have basically the whole of the data warehouse, and also after just showing all the tables, that how they look like and all the sources, and every of the terms is kind of a link which refers to a definition of that term. And after, you should continue with building this metadata base. It's basically these kind of definitions and also responsible persons and so on. And then if you start with these two, then probably it can be a successful data warehouse if you also involve the users from the very beginning. And then we will see in a few slides that what does it mean that the data warehouse is successful. It's very easy to measure. Okay, so yeah, you have some main success criteria, like you have to have a BI strategy that we were speaking about, and also you have to have a huge support from senior management, and it should be developed both business and IT, and it's a common effort. And then you should test from as early as possible, or you should start the test as early as possible and agree on the acceptance criteria as before doing the tests. Okay, so if you have okay, and then after you created all of these requirement analysis, and then you mentioned that what will your data warehouse do, so that is a kind of logical design, then you just explaining that what are your input tables and what kind of reports and output tables you would like to do, and what are the middle steps, so how will you aggregate the tables, how will you clean the tables, and how will you merge the tables, and how will you store it in some middle layers to get this kind of expected results. And then you can use some kind of tools like this Oracle Warehouse Builder, which can, for recording all of these information. And then basically, if you have a tool like this and you already recorded and explained for the system that how it will work, it can just translate it to codes, and then it will never work, but then that you can use it at least as a base. So now we can check the physical design. So if we have a data warehouse, like this is mainly this kind of telco situation or this quick telco DM, but it also can be a data warehouse or a telco data warehouse where we are zooming in of one of these data marts. So, but I just wanted to show this because then we can see that, okay, what kind of input data we have, like for example, the CDRs and so on, and how we go to this dashboard and reports. So usually we have a staging area where we are expecting the results. In case of a data warehouse, there are some structures which are expected, but nowadays it's less and less critical. Okay, so, and then from this, like a data CDR, we should do some kind of aggregation and data cleansing and basically a kind of normalization in some cases. But then we can just store it in a year, month, day level, for example, and by tables. So for example, here we have data CDR and voice CDR, and then in this middle store or this central layer, we will have mobile data usage, we will have mobile voice incoming, we will have mobile voice outgoing tables, maybe we will have an A/B graph, we will have some customer master, but not only one. This is just in the smaller data warehouses, but some customer related tables. we will have NPS, for example, NPS fact, and so on. And yeah, and that's it. And then we still on this layer, in this ENDS or INDS layer, we already have two kind of tables. So one which contains this kind of fact with some ID, with some customer ID, MSI, SDN, and so on. That's I will not detail now, but we have some ID and then some fact data. And then we also have some dimension table, which is, for example, this customer master, which contains that, okay, this MSI SDN belongs to this user. And then the owner of this MSI SDN is a woman, and then they are living here, and so on. So a lot of this dimension data. And then this has a kind of valid from valid to date as well. Like the information is valid from this time to this time, because maybe after they moved, or and so on, or after you just modified their date of birth. Okay, and then these are separated very well. So these are just smaller tables, but in this case, you also have, in some cases, some joins, like joining some of these tables. But mainly, yeah, you just storing everything separated. And in case of the data marts, that you are start to apply some business logic as well, and do the main part of the integration. And then you can make some data utilization and data usage table, voice usage fact table, and so on, and the product dimension table. And then in this case, you will have fact and dimension tables. So the fact tables contains these the numbers, basically. So what was the usage, how many minutes, also the data utilization, like in, or the data usage, like how many megabytes they used, and so on. And I will a little bit later will speak about the dates and what is the main difference between these two layers, so how is it organized. Okay, but then you have this ETS, extract transform load, which create this. So it's always, this ETS are defined that, okay, what are the input tables? So this is the extract part, and then pulling it. The transform part refers to that what you have to do for getting the expected output, and the load part is loading it into the next layer. And then after, this is just an example, you will have a data warehouse, for example, in Google Cloud GCP, Google Cloud Platform, and then you have a certain project. You have there the several layers. So yeah, every of these layers just became a folder. And then you have the table name. So what is this table here? And then also you can keep it in a year, month, day, resolution and granularity. But in some cases, it can be another, but this is a kind of partitionized partition. Yeah, these are in partitions. Okay, so then let's speak a little bit about these data marts and what is the big difference between the data marts and this middle layer of the data warehouses. So the data mart is it's comfortable to use for the given business case. So it's very easy to create reports, for example. For here, it's very easy to use it for analysis. So these are already some kind of aggregated tables on the right level, which was fast for loading to the dashboards and so on. So let's check an example. Maybe we are data scientists, and then we have a goal of this retention data mart. Then we want to be able to do a churn model, and we want to be able to do churn related reports. So how a churn model look like, or let's find how we'll churn. Then, okay, let's check the churns from the previous year. So the previous 1 year, we can check the churns. And then, okay, so let's see their past data. So how these churners behaved. So yeah, they are churned in a certain time, but then we have to keep a gap before that, because then they already, for example, announced somewhere here that they will churn, and also they or maybe we need also some time for reaching them with a campaign. And then also, yeah, it might be captured when they are still active. It's always this gap time. It depends on the definition of the churn and also of the environment. But let's assume, for example, now we have 2 months of this gap time, but doesn't really matter. And yeah, so that we can analyze the data before, and then we can check their data history. So for example, we can check that, okay, 2 months before the churn date, that what was their monthly data usage for the last 6 months, how is it changed? So is it just decreasing or increasing? How many times they are complaining customer service? Like what is the average NPS of their zip code? And then, or what was the average NPS on their zip code during this period, and so on. So we can ask all of these questions. After, we can check those guys also who were not churned, who were loyal, or who are satisfied with our services. And then we can compare these two kind of histories, and then we can build some model which can differentiate these two histories from each other. And now, when we want to know that who will churn in the future, we can just check the latest data of all the customers we have. And we can run the model, so we can check their patterns. We can check their patterns. So we will see here that, okay, these 2-3 customers are suspicious. And then we can make our predictions. So because we observe the same patterns as we earlier observed of the churners comparing with non-churners, then probably they will churn, or we have to handle these customers. Or it can be a product take-up, or it can be anything like this. So when we are doing a data mart for this, then it should be we should be able to use it in a very comfortable way. So the best is if we have a report date, which is coming in all days where possible. So yeah, in the past few years, we have a report date, and for every day, we are calculating for all the customers all of these different features, like what was the past 3 months of data usage related to that report date. So for example, if this report date is 1st of March, then we are getting all the information from here, from this normalized data store between 1st of Jan and maybe 31st of March. So this first 3 months, and then we are aggregating it to one data point, and so on. So we can do all of this. So this should be some organized around the report date as relative date, and then we can just aggregate everything up. So it's always can contain the latest information we have. So it shouldn't be as normalized, and we don't have to follow very strict rules like in the integrated normalized data store. It should be comfortable to use, but also it should be somehow organized. So a data mart is good if a data scientist and the data engineer do it together while arguing a lot. Okay, and then this kind of so with this last slide, so when we can say that the data warehouse is good, that is, we can say if it's used. So if it's used by a wide audience, and if it is the single source of truth within the organization. So and for getting this, we can just go through on the earlier step, like add the most resources to the requirement analysis on the beginning, and involve users as much as possible also for the development, and start testing very early and get a continuous feedback. Okay, so this first part has finished with this. Maybe if you have some questions now, that would be nice to hear. And after, Bram can continue with his presentation.
Based on your experience, when you have all these recent newer data sources, right? Like the ecosystem, even if you look at telecoms, but even in digital banks, like every new year or half year, you have a new source, the streaming, you have Google Cloud, which is all integrated services. Like, is there a project management methodology that we have seen across the board where somehow this very quick integration of new sources to these existing warehouses or lakes are happening? Like, because indeed, you should document everything. You should have all the definitions, the business goals, but in reality, there's a lot of side work happening for a lot of small, quick projects. Is there a best practice around them? And then, or it's still evolving? Yeah, I guess that's an interesting for someone from an external perspective.
Okay, so I would just go back here. So first, this data warehouse is like created, and after these things are happening, and it's also happening because of these newer data sources. So in some cases, like you would like to get some new data source, so you just quickly just somehow get it. You just put it to the one ready-to-use solution. So for example, with Amazon Kinesis or anything like this, or AWS Kinesis, you can just start using it. And then after, for example, if it's a picture of t-shirt and you want to get some t-shirt features or anything like this, then you can just create some quick model for that. And then you can load it to your data warehouse as a new source. And then maybe you can get it back, but it's again not too nice. So after a while, when there are a lot of these side solution happening, then you again have to make some kind of data warehouse project, or at least some kind of consolidation. And you also have to be aware that everybody from the company is somehow involved, because maybe that will be also useful for them. But Bram will speak a bit more about these kind of new challenges and solutions. Was it an answer?
Yeah. I mean, I'm looking forward to Bram's answer. I'm just saying the reality is that, you know, every department is setting up their own little cloud-based solution. And maybe even if you have a 360 project, then through some API, they try to put everything for a moment together. But yeah, I see it more and more challenging to really have like a full 360-degree view of everything.
Yeah, so it's very painful to try or to start a data warehousing project, even in bigger corporates or banks, because it's already tested a lot, it's already built, it's already has a huge effort of work inside. And then when you are just migrated to a totally new technology, then you can basically just start it almost from the beginnings. So that's why they are afraid a lot. But of course, that will be the long-term solution. The question is just when.
And then, yeah, indeed, the last question is in what you're saying, basically, that the new data warehouse is more like the cloud-based vendors, different sort of data stores. So a few years ago, it was all IBM and Metadata and some Oracle pieces, but is there some other than Amazon and obviously Google Cloud, or are they actually becoming, even in our projects, like 90% of what you see? Because I feel like that. But it's literally between BigQuery, AWS, and a little bit of Azure, and then a lot of the on-premise new data warehouse project. I don't remember when was the last time I heard about some new on-premise data warehousing project. Snowflake. Timothy is just telling me Snowflake is the new Metadata.
Yeah, so there is this Gartner quadrant also for this, and then there are a few new players all the time. But yeah, so we have this Microsoft Azure and AWS and Google Cloud. I mean, for this kind of platforms, and also I guess Bram will speak about Databricks,
which is also a combination with AWS. So
yeah.
Databricks is on everywhere, right?
Yeah. Yes. Or
Google. Good afternoon, I think, to most of you. My name is Bram.
Hi, Bram.
Hi, Juan Pablo. Yeah, so first of all, thank you for inviting me. A little bit about me before I get started. So I used to work for Lynx Analytics, with my last location being Singapore. That was pre-COVID. And nowadays I live in Munich and I work for Databricks. I had a great time working with Lynx before I joined Databricks, so I'm very happy that you guys invited me over to talk a little bit about data lakes, this lakehouse architecture, and I will tell a little bit about how we think about those things here at Databricks. Actually, the thing that maybe unifies the two is Spark. So when I started at Lynx, I worked a lot with Spark, and I still do that, of course, at Lynx, and with Lynx Guide, of course, at Lynx, etc. Yeah, that's about me. Feel free if you at one point you have questions to unmute, or I don't know how you want to do it, Martin, whether you want to take questions at the end. Both are fine with me.
Yeah, both are fine. We will have a bit of a question or this kind of the discussion session at the end, but yeah, it's also possible anytime.
All right. Yeah, and I joined a few minutes early just to test my connection. I saw on your slide this data warehouse that's being central. So I might talk a little bit about a slightly different concept, like the next step, how we think about data warehouses. You also mentioned, I saw somewhere, the Lambda architecture. I think you will be in for a treat. I hope to tell you about a different architecture with regards to that. And yeah, one last thing, it was mentioned Databricks on AWS. We're actually, since last Wednesday, we're also on Google Cloud, and we are already on Azure as well. So we're truly multi-cloud right now. Yeah, so a little bit about Databricks. So what we do is we provide a platform where everyone from the data team can collaborate together. So whether you're a data engineer, you're a data scientist, or you're a business or data analyst, we try to make this platform as simple as possible for all of these personas to work and collaborate together on big data sets. We're a global company with over 5,000 customers right now, more than 450 partners. And most of you might know Apache Spark. So Apache Spark was originally created at the University of Berkeley. And the people that created Spark, they are also the founders of Databricks, and they are still with the company as of today. Apache or Spark was donated to the Apache Foundation, so it's open source. From Databricks, we also open sourced other products as well. So you have Delta Lake. That's something that I will talk a little bit about today when we talk about data lakes. MLflow, that's also open source. It allows you to track different models and model experiments. So I used to be the guy that would track all my experiments in Excel spreadsheets, which hyperparameter configurations led to my best result. And with MLflow, you can sort of automate that. And Redash is a company that basically joined the Databricks family last year, and they also have an open source product that allows you to build dashboards, which is now integrated in our SQL Analytics product. So that's a little bit about Databricks. What I want to talk to you about today is, I will start with data warehouses. I will talk about some advantages, but also some of the challenges with data warehouses. Then I'll talk about data lakes, how they address some of those challenges in data warehouses, but also they also introduce some challenges. And then I will introduce this lakehouse concept that we've introduced at Databricks that tries to bridge the gap between, or brings the best from both two worlds together. After I've introduced that, I want to jump back to data lakes, talk a little bit more about data lakes. And I thought then it might be interesting for you if I bring on a practical example. So that's this open source Delta Lake, how you can use that to make your data lake a bit better. And then I can show you a live demo of how Delta Lake works. I will do that on Databricks, but Delta Lake is an open source product. So if you're working on premise on Hadoop, you can also work with Delta Lake. It works on AWS with S3, but also on Azure with ADLS, or on GCP as well. So yeah, I'll start with the data warehouses. So data warehouses, they're actually already quite old. In the 70s, 80s, companies started to bring data together from all these different systems. They ETL'd it, so extract, transform, load, and they brought it into a central database with the idea we want to do business intelligence on top of it, do some reporting, which was actually very great. And these data warehouses, they support these nice technical features like asset transactions and so on. But they also had a few challenges. So they had not really support for unstructured data. So suppose you have to work with video, audio, text. It was hard to do real data science and machine learning on top of these data warehouses. Limited support for streaming. So there's often quite a big of a delay before your data from your source systems becomes available in your data warehouses. And lastly, data in these data warehouses tend to be stored in a closed and proprietary format, especially these days. Think maybe your typical Oracle database or data warehouse system, they are licenses, very expensive. You store your data in there, but it's in a proprietary format. So even that you store it there, you cannot really open these files or something like that. A bit after the data warehouses, that's when the world started to move to data lakes with Hadoop. And later on, when cloud came along with AWS and the other clouds, people started to put their data into these data lakes. So think HDFS, Amazon S3, Azure ADLS, Google Cloud Buckets. They start to put their data in there. And this was really great because now you could store your data in an open format like Parquet, ORC, something like that. These data lakes also tend to be relatively cheap, especially on the cloud. They're highly durable. You do not pay that much since, as mentioned, data format is open. So you really stay the owner of your data. And this is something that maybe some people on the call will also realize, that once you started to work with these data lakes, you were still not very happy. Reason is sometimes the data in these data lakes became a bit messy, so you didn't really trust the data in your data lake. If you want to do if you wanted to get good performance out of your data lake or wanted to support a lot of fast BI queries, then the performance in these data lakes did not really meet the expectations. So you would first ETL it out of your data lake, put it in a data warehouse, and then people could query from that data warehouse. And what we call it sometimes, because of all these things, data lakes tend to become data swamps at those times. So really, because we cannot really trust the data anymore in those data lakes, that became a challenge. I will talk a bit more in detail about that in a minute. Now the question is, can we not combine the best of those two worlds? So these performant data warehouses where we had asset transactions, we were actually quite happy with the way we could do BI and reporting on top of that, with the best of these data lakes, open source formats, highly durable, scalable, cheaper. So could we not combine the two? And that's what we introduced last year as the lake house concept. So it brings the best of both worlds together. And the idea is to build a data lake, what we call a curated data lake, that is highly performant, where you can really trust the data that's being ingested in this data lake, and that you can serve all your use cases from these data lakes, so that it really becomes your ground, your source of truth. As mentioned, you could then pull all your data into your data lake, and you would have one platform for every use case. How we think about that at Databricks is, at Databricks, at the bottom, you would have your data lake. So we're in the cloud, so we're not on premise. So think the bottom layer, S3 or ADLS, something like that. You would then store your data in an open source format. That's where Delta Lake comes in. This is an open source format that's based on Parquet, and it adds a few tricks to make your data lake more reliable and performant. Then we have our Delta engine that makes it easier and faster to query data from your data lake, and from there you can serve your different use cases. Now, I want to talk a little bit about the elements of these data lakes. So something that we call the Delta architecture, a little bit about the Delta storage layer, and then the Delta engine. And I think since you mentioned, Martin, the Lambda architecture, so if you store your data in Delta, what you can actually do with this Delta architecture, you can actually combine streaming and batch into the same pipeline and write that out to the different tables. So that way you do not have to maintain multiple pipelines. You can actually combine the two. And the reason is I can get into that in a little bit. But what we basically mean with the Delta architecture is a multi-hop model where you would pull your data into your data lake. This is the raw data. So think you extract data from different operational systems. You would put it in your data lake as it is. This can be in this Delta format. It can also still be in the raw format that you've extracted it. And this will be the source of truth from which we're going to work. This first layer is what we call the bronze layer. It's also sometimes known as raw or the ingestion layer. And from there, we are going to clean up our data. That brings us to the silver layer, where or sometimes called filtered, cleaned, augmented. And basically the only thing that we're going to do there is we're going to clean up the data from our bronze layer, and we are going to store it in our Delta format. We're going to remove duplicate records, for example, fix broken records, those kind of things. But the data in silver is still quite raw. It's just that we fixed a lot of the issues that we had in our bronze layer. And then from silver, we can jump to gold, and gold, or called business level aggregates or even features, is what you could use for your BI reporting or for your machine learning models. And those are really the aggregates, yeah, that start to get some meaning in terms of business value. And then as you can see, over time, the data quality basically improves the way you process it. And with Delta, as I mentioned, you can combine your batch and streaming jobs in the same pipeline. So you do not have to maintain such a complex Lambda architecture because of it.
Maybe if I can have a question here, like,
yeah.
For example, the data that you have, or then, for example, it can be a video stream or kind of like web streaming data, or no, so streaming data, or kind of these clicks from a website or anything like that. Mm-hmm. So how you can handle these, or what kind of these definitions you should do? And also some other question, that these are all stored, or these are just a kind of this metadata you are adding, and then it's just do everything on the background, maybe at once. But the first question is this data, this video and others.
Yeah, so if you would have like a click stream coming in, I think you mentioned kinesis, for example. What you would then do is you would hook into that stream, you would write it out to your data lake, so your bronze layer, and you would store your data there. But it might still be right from a stream that you get some duplicate records. The data is still quite raw. So what we would simply do is we would connect to that stream and we would write it out to our bronze table. We get a lot of records. Then what we can do is, if you really want to make it fully streaming, so what we actually do is we store the data between these hubs. But what you can build is with Spark structured streaming, for example, the data arrives in your bronze layer, you save it. And from there on, you automatically pick it up again. That's from a Delta format. To make it a bit more technical, that can also be a source for streaming. So you would write your data into your bronze table, and you could directly stream from that table in your data lake again to a next process that would clean up the data, write it into your silver table. You could have another streaming process that writes it out into your gold table. And I forgot your second question. Could you repeat that one?
Yeah, so that one is just how is it exactly working? So why is it different than a data warehouse? So if you are just writing out in all the layers, it's basically almost the same. or the main difference is that as the data is arriving, as it basically just goes through on all of these processes automatically, so you don't need a kind of data refresh, but you just have to define these processes, or what is the difference or the main difference?
So conceptually, this is actually quite similar to it. You can also have this process in a data warehouse. If you would have your data warehouse, this concept in that sense, it's not new. This is how many companies address it. You have your raw data, you ingest it, you clean it up, you build business level aggregates on top of it. And that's what you can do in your data warehouse, except when you do it in your data lakes, you get some of these advantages that I talked about earlier that you have, like durable storage, open source. So you stay owner of your data. You can easily migrate to a different vendor, these kind of things. So in that sense, the methodology stays the same, or like conceptually, it's accepted. We can now execute this on a data lake like S3, ADLS instead of a data warehousing system.
Okay.
What is quite unique, and I will talk a little bit more about that, is that you can combine streaming and batch in the same pipeline. Yeah, a little bit about this Delta storage layer. So what you can do is, because of the data lake, the data is stored consistently with Delta. I will talk about all of that in a minute. We also track some metadata about it. It can handle variations in your schema. You can actually track versions of your data, go back to previous versions of your data. You can merge and update data as it arrives. Then this Delta engine. So this is something that you would build on top of your Delta lake. This is what we have at Databricks, which also gives you some edge features like Delta caching, adaptive query optimization, which is in Spark 3.0, and so on. So yeah, once we combine all these elements together, so data lake on S3, a durable storage system, we store our data in Delta Lake, and then we have a query engine on top, for example, Spark 3, that already gives us a good ground to serve multiple use cases from our data lake. This was in a bird's eye view, what from data warehouses to data lakes to these lake houses. And now I want to jump back to data lakes and basically reiterate some of the points that I talked about. So when these data lakes came about, starting with Hadoop and then later on in the cloud, they were actually quite nice compared to data warehouses. So I might challenge some of the things here that you mentioned in your talk, Martin. But one of the advantages of data lakes is you can actually store huge amounts of data. These data lakes are, especially in the cloud, are very reliable, very durable. They are cheap and basically of infinite scale. So you can just pour all your data in. You can store all types of data in your data lakes, and you can store your data in open standardized formats. So Parquet is like one of the most popular ones. If you have worked, for example, on Hortonworks distribution of Hadoop, you might be more familiar with ORC. So that is all very great about data lakes. They still have some challenges. And maybe if you come from the data warehousing world, you might understand these challenges even better. The first challenge is it's hard to append data. This might sound a bit weird, but if you write out a lot of data to your data lake, it's actually quite hard to make all of the data when you write it out to become visible once all the data has been written out. So what you can actually sometimes see is that some data is already written out to your data lake and other data is still being written out by the process. So as an end user, you might have a inconsistent view of the data in your data lake. This is especially the case in Europe, but now also in other parts of the world. So you have this regulation called Gdpr, or in California, the California Consumer Protection Act, which basically gives consumers the right to ask a company, delete my data, these kind of requests. If you've worked with data lakes, especially as a data engineer, this request is quite hard. So suppose you have this huge data lake with terabytes of data, and now there's one customer that tells you delete my record. How are you going to implement that in your data lake? That's actually quite tough. Mainly because these files are also technically, these Parquet files and ORC files, they are immutable, so it's hard to deal with. A third one is jobs failing midway. So if I would write out data to my data lake and my job stops, gets disrupted, can be because of anything, then half of my data might have already been written out to my data lake and the other half not. So I would have to manually repair that. Again, if people query the data lake, they see an inconsistent view of the data, or the table might even be broken. Real-time operations. This is basically like a number one, appending new data on steroids. So if you have a streaming and batch pipeline that write into the same table, it becomes even harder to get a consistent view of the data. It's costly to keep historical versions of your data. So suppose for compliance reasons, you have to show how your data looked like at a particular point in time. That's quite costly to currently do that. It's difficult to handle large metadata. Maybe some people on the call have worked with big Hive meta stores, and what you see is if you have a data lake and you pump a lot of data into it, then at one point it's not the data itself that becomes the bottleneck, but it's sometimes the metadata, because the metadata about the big data becomes big data as well, and your data lake doesn't become so performant anymore. Too many small file problems. This is actually a typical Spark problem. Suppose you have a lot of different small files written out. What happens is Spark will mainly be working on, mainly be loading all these small files, fetching what are all the files that I have to work on, opening them, quickly doing a computation on it, because it's just a small file, and then closing it. So most of the time is actually not being spent on computing, but on other things. Yeah, basically it's hard to get good performance out of your data lake. So it can be as a result of too many files problems. It can also be that your partitioning is not being done correctly, etc. And data quality issues. Well, this basically just sums up multiple of these issues that I mentioned before, that as a result, you might get a table on your data lake that suffers from some data quality problems. And what I thought what might be fun to talk about today with you is this open source format Delta Lake, which is basically a format like Parquet. It's built on top of Parquet, and next to it, we just store some metadata and apply a few tricks. You don't have to be on Databricks to work with Delta Lake. You can go to the website delta.io and download it yourself and work with it. And what Delta Lake does is it addresses some of these challenges that I mentioned before. We say it adds reliability and quality to your data lakes. When you use Delta Lake, we say that helps you to build a curated data lake. It brings the best of data warehousing and data lakes together. So now what you can do is you can do asset transactions that you had on your data warehouse. You can now also do that on your data lake. And as mentioned, yeah.
This what is this AC transactions?
So that's for example, it stands for atomic consistent. I forgot the I and the D.
Durability.
durability, and the I.
Marketing buzzword.
The I is isolation.
Yeah.
Isolation, yeah, thank you. To be honest, I always forget those four. But in practical terms, what it basically means is if you, in your data warehouse, if you write data to your table and your job fails, someone that would read from that table, he, for example, doesn't see that that data, so he doesn't get a corrupted table. Whereas if you have your data lake, you write out some Parquet files, your Spark job fails halfway. It can be the case that some data is written out, some data hasn't been written out. And as an end user, if you query your table, you will still see that data. It can even be that you cannot load the table anymore. So these kind of features prevent those things from happening. And that's what this Delta Lake format basically contains. So it's something that we lost when we moved to data lakes, and this storage layer tries to add that back. The way it technically, for people that are interested, the way it basically adds that back is it saves the data, and it saves all your data in a Parquet format, but next to it, it keeps track of a little folder with metadata. And in those metadata, that metadata folder is basically a transaction log. And every time data gets written out to your data lake, at the end, when all the data got written out, it commits it to this transaction log. And what end users do is when they read from a Delta table, they first go to the transaction log. In the transaction log, they find out what are the files in my data lake, then use that to retrieve that data. And this gives us, this solves a lot of the problems that I mentioned before. That's actually what my next slide is about. So I've listed all these issues here on the left, and then on the right, I will tell you how you can address those when you use Delta Lake. So these first 5, from hard to append data to costly to keep historical data versions. With Delta Lake, since we make every operation transactional, so it either succeeds or it fully gets aborted. That's what we store in this Delta log, so this transaction log. So every write to your table gets written to a JSON file. And in this JSON file, it's basically committed what data has changed, which Parquet files have been added or removed. Every write basically adds a next JSON file. So you start with 0, then 1, 2, and those numbers correspond to versions of your table. Every 10 commits, this data also gets checkpointed into a Parquet file so that we can retrieve that data also quite fast, and we do not always have to process all the historical JSON files. So to give an example, 0 was the initial state of our table. Then there was a process that wrote some data to our table that created a new version of our table in which it added 2 Parquet files. And then it did an update on the table, so it removed a record and added a record, and then it created a new version of the table. For the end user that looks at your table in your Delta Lake, they will always see a particular version of the table. So when a process is still writing out data for a particular version that has not been committed, the user will not see that data because they will look at a particular version of the table and all the files that correspond to that version. Well, yeah, and this goes on and on.
Sorry, Brian, quick question.
Yeah.
So what are the kind of edits that you support on the Parquet files? Like how would a JSON file look if you updated the record? Like you would say that, I don't know, record number 10 in the Parquet file change, or it's always just on a file level that this shard was replaced with this other shard?
Exactly. It's the second point that you mentioned. It's on a file level. So it doesn't mention the records that got changed. It mentions the files that got changed. Because yeah, since these Parquet files are immutable, so suppose you have like hundreds of Parquet files. You have 100 Parquet files in your data feed, and you want to update one record. What basically would happen in your transaction log is it would mark one Parquet file as being deleted. That's the old file. And then it will mention a new Parquet file being added. That's with the records from this previous Parquet file, and then one of the records being updated, and that gets written out.
Okay.
I hope that makes sense. Yeah.
Bram, quick question. Sorry, quick question. Is there any benefit for Delta Lake? I just recently started working on Delta Lakes and was thinking about this actually. Is there any benefit to use Delta Lake over Data Lake, assuming that you are interested in this explicit versioning feature? Say that you have versioning handled on your own, right? Maybe you have your own method, your own algorithm, your own logic, whatever, right? Is there any benefit over the data lake, like kind of classically raw data in a raw format, essentially?
Yeah, so it basically, if you use this Delta Lake format, it addresses these challenges that I mentioned before. So suppose you have this this raw format. I'm thinking like, so suppose you have a process that writes out this raw data to your data lake the whole time, and at one point it gets interrupted. Some raw data might be written out, some data might not be written out, and you would have to manually then sort out what got written out, what didn't got written out. Then in your Delta Lake, it will not have even like registered that transaction. So if you go to your transaction log, you go through your transaction log, you will not see that transaction. So you do not, like, Delta Lake basically doesn't know about the existence of that data. So it doesn't corrupt your data lake. So these are some of the features that this Delta Lake layer provides you when you use it. It also helps, like, suppose you make a modification to your table and then you think, oh, I shouldn't have modified that, or I did something wrong. You can then actually just go back to a previous version of your Delta Lake and restore that version. So those are also some of the benefits that it gives. One more thing, maybe if I jump to the next part, it's difficult to handle large metadata. This also ties into that. So if you have your Parquet table, it would save. If you create a table on top of it, it will register that metadata in your Hive metastore. But if this data becomes large, then that can become the bottleneck. It also has some other issues, and that's what I want to demo you later on to give you a very practical example of how this looks like in practice. But because with Delta, the metadata is stored in the same folder, not in an external metastore. So one of the things is if the metadata can become quite large because we have an engine that can handle large data, that is Spark. So we can directly work with the data there. And the other thing is Spark will directly look first at the metadata, figure out what's the latest version of the table or the version that I want to read, and then load the files that correspond to that. The too many file problems and poor performance. This is, I will be honest here, this is like a feature that's in the Databricks version of Delta Lake, not in the open source version. So when you're on Databricks Delta Lake, what it does is you can run an optimize command. So if you have written out a lot of small files into a data feed that uses Delta, and it becomes quite slow because of that, you can run optimize on that particular partition or even that whole table, and it will merge small files into bigger files that you can, and those are being registered in a new version of your Delta table. Then you can use that, and that can really speed up your queries from Spark. And as a last thing, and this is also something that I want to demo with Delta Lake, and this is in the open source version as well, It also supports merge into, so you can say, I want to write some data into my data lake. If a record in this data already exists, I want to update it with the new data. If it doesn't exist, I want to insert it. And if you want to write this in a normal data lake, it's actually quite challenging because you have to figure out what are the records that are updated, what are the records that are being inserted, what are the records that are not affected, move those to a different folder, then write out the data, and then remove the old folder, copy back the data, and with Delta Lake that basically solves that for you in one query. So it makes it quite easy for the end user to do that. I think, there's also in the latest version, you can create some constraints on top of tables. So I think actually that part is in Databricks. What Delta Lake open source can prevent you with is also that someone cannot accidentally write into your table data that doesn't conform to the schema. So such job would fail. So it prevents someone from accidentally writing out the wrong data to your data feed. But it also supports things like schema evolution, for example, in case that you're fine with that. It's actually quite simple. If you want to use Parquet or Delta instead of Parquet, you can just replace Parquet with Delta. This is on Databricks. If you're not on Databricks, what you can do is you just have to add one Maven dependency to your project, or if you use PySpark, there is also an option to include the Delta package, and then that will be added as well. And from there on, you can work with Delta. And I would now just want to show you quickly how this looks like in practice. So I just want to show you what happens if I write out to a normal Parquet table. Then if I write out to a Delta table, what are some of the differences that we observed there? And then I want to do another experiment with that as well. Before I do that, questions about that?
Yeah, I just have one. I've used BigQuery in the past, and would you know any comparison between those two? I kind of feel it's quite similar in terms of BigQuery being a very similar technology like this.
Yeah, I actually I would have to look it up. I do not have performance comparison figures on top of that. Yeah.
But concept-wise, in general, because even it kind of separates the data, because then it becomes cheap, where it stores in the G Cloud buckets, and then there's a BigQuery engine on top of it, very similar.
Yeah, yeah. That part I know. I just do not have any performance figures in that sense for you. I have actually seen at our customers that when they use Delta, they really they can definitely see performance benefits there. And it also helps them really if you have these use cases where you have some streaming and batch writing into the same table. This merge into command is also quite powerful. I've seen that customers like to use that a lot. And with the on the Databricks side, you have the optimization, the optimized part as well, and that's also really powerful because this small file problem gets solved because of that. Sorry.
I see. Thanks a lot.
I'm not 100% sure. I may be wrong, so if somebody knows about that, but I don't think BigQuery does any of these transactional stuff. I think BigQuery is much more like it's your business, how you put your data there, how you keep it consistent, and it's more about querying. But I don't know, maybe I just don't know this feature.
Yeah, I see. Yeah, because I was just curious if it's very similar platform, but yeah, I think then this platform is adding much more value to that than comparatively to BigQuery.
But isn't Delta a model and a file type, whereas BigQuery is actually the environment? Bro, you can do Delta on the premise, you can do on Databricks, you can do wherever you want, whereas BigQuery is already the environment on its own. I don't think you can compare those two.
I see. Okay, I'll still look it up.
Yeah, it's the columnar database. It has a cluster for the storage and for the computation purpose.
Okay. Can I have a question?
Yeah, of course.
Okay. So that one is that how it is not only like this, not only maybe Databricks solution, but all any other these data lakes and data lake houses. So how enterprise ready are these? So can you give these very fine grants and others? So maybe just one customer or one customer groups like access for maybe not the whole table, but maybe in a partition, like for example, for just a seg or the data for a segment of the customers and maybe other user groups.
So yeah, what I can say about that is from the Databricks perspective, but I'm sure that other types of vendors from data lakes also have solutions for that. Is we have table ACLs, for example, so you can grant access to particular tables. You have, when you're on AWS, you can assign roles. What kind of roles on AWS can read from particular S3 buckets? What kind of access do they have? We have then this layer on top with ACLs. We also have something that's called credential pass-through. So basically a user has particular credentials, for example, from AWS, and those credentials are being passed through when he tries to read the data from S3 through a Databricks cluster. So these kind of things are definitely being added to data lakes. And yeah, I'm from Databricks, so I can tell you definitely for sure that we have that, and we are adding more and more of those features. But I'm also sure that other vendors have these types of solutions as well.
Okay, thank you. Maybe one more question: that's how painful to migrate. So let's assume you have a data warehouse, like a bigger one or a mid, which you just built for 5, 6, 7 years, and also with the many UAT tests and others with your users. So how painful is to migrate it to the cloud, or is there any better?
Well, I think migrating things is always a pain. It will always be work, and especially if you have worked for years on something, it is, yeah, there is no like a golden ticket that with one click you have migrated everything. I do think, especially, this is like my personal opinion, like cloud is the future. A lot of these data warehouse technologies are already quite old, quite expensive. What I mentioned, you have these closed proprietary formats, and with these data lakes, they're very durable. You do not have to care as a company anymore about that infrastructure that's managed by the cloud provider, whether it's Google or AWS or Microsoft. So yeah, it is work to migrate it, but I think that's definitely where the world is going, to data lakes in the cloud.
Okay.
One more question. So how much all this is married to Spark? Like if I want to read and write Parquet files using something completely different, I can still use the Delta interface, like have an API which just, I don't know, gives me a list of files or something like that, and I can start transactions, or I really have to read and write with Spark?
No, yeah. So there is actually quite recently, I'll have to look that up for you. Someone also worked on like a file API that you can just call, that will list you all the files in Delta. So then you're not dependent anymore on Delta. We also see that other companies are starting to add Delta connectors. So for example, Azure Synapse, which is like I would say maybe the BigQuery solution from Microsoft and Azure, they also have like a Delta connector, so you can directly connect from there to a Delta lake. So Delta lake, this format does seem to get adapted by more and more vendors as well.
Okay, thanks.
I think I have 10 minutes. I can can give you one, like, it's a very practical thing. Which shows you some of the things with the metadata when you work with Delta compared to a basic Parquet table. And for the people that have worked a bit with Spark, maybe this will test your knowledge as well a little bit. So I'm now currently in Databricks. I'm in a notebook and I will just run some cells. Let me just run all for the sake of time. So what is it that I'm going to do? I'm going to read in some retail data. It's a CSV file from this location. This is the schema that the file adheres to. And I'm going to write out the data to this location. So a base path, which is defined above, and customer data. I'm going to write it out as a Parquet file. That's what you see over here. I partition by country. I do override. Simply the reason for that is I want to run the notebook multiple times and I don't want it to crash. Then what I do, don't care about the errors. There's like an exercise at the bottom. What I then do is in Spark, I define a table on top of my data. So I say create table if not exists. I call it customer data. Tell it that it uses Parquet. As the options, I provide the path to my Parquet data folder. I have to call MSCK repair. It's a Hive table, so I have to repair the metadata that all these files that are written out now get registered in the Hive metastore. I run a count star, so I query my data from the customer data table. I do a count star, and that's what I print over here. So you see the number of records in my table. And now what I want to do is I want to read in some new data. So I have this schema over here of the new data, a mini batch of data that I want to insert. I read it again in with Spark. I do a count. I can see that there are 36 new records in that table. And now what I want to do is I want to append that data to my table. So I write out my data in a Parquet format. I partition it by country in a mode append, and I save it. And then I count or maybe I should do that here. I can count the data in my table. So I can do Spark the table. What was the name? Customer data. I should probably just copy this. Spark.sql. Wait, I should not have run the whole notebook. Okay, that doesn't work. What you basically see in this cell, I also have the cell over here. You actually see this record. The old count of records is this, and the new count of records is this. So what I've done is let me briefly remove this cell. So I computed this original count over here. Then I go back here, I print out this original count, and I also print out this new count. And this new count, I do it again by just running this query select count star from customer data, and then I show that. And then the question is, why are these counts the same after I've appended my data to my Parquet data? I might have already spoiled it a little bit. I'm sorry about that. But there's someone that worked with Spark that might know the reason for this. So remember that we store our data in this Hive metastore, and when we write out data to a data feed, then it doesn't automatically update our metadata in the Hive metastore. So that's why these two records are the same, or the record count. Furthermore, what also happens is that in our data, if we look at it, there are a few countries that we have added, some new partitions that were not in our original data. And these have also not been detected yet. So that's what we summarize here in this data. When we look at it, we have some records for Sweden. We do have this Sweden partition already, but the Hive Metastore basically doesn't know of these new files that contain these 19 new records. And it also doesn't know about this new Sierra Leone partition. If I scroll a little bit down, so what is it that we always have to do? We have to run MSCK repair table that refreshes our table or our metadata in the Hive Metastore. And after that, we should see the correct data count. Whereas if I would run this with Delta, so I would do the same query as what I've done above. I would just read in, I would first create one Delta table from the original data. I will write it out to this path, read in the original data with this part, write it out to my Delta table in the Delta format. I also partition by country. And then I append the new data. So this is the same mini batch of data. I append the data. And if I then do a count, I directly get the correct count. And the reason for that is that the metadata is stored basically next to the data itself. Maybe, yeah, so we could even, let me quickly show you. And hopefully I can show you how that folder looks like. So you can actually see, if I explore that folder, you can see all the data that's written out over there. And you can also see this at the bottom, this last folder, this Delta log folder that contains all the metadata. And if I will go into that, you can see that there are these different commits in this folder. So our initial version of the table that includes initial data that we've written out, and then a new version of the table with the new records. So this is just one example of Delta Lake, how it helps you to work with the metadata and that you do not have to run this MSCK repair the whole time. I had another example, maybe I will just briefly skim over it. So that's with the upserts. What I talked about with this merge if merge into, so if exists, update, if not, insert. Something like that does not come out of the box with Spark if you work with Parquet, but if you would run it with Delta, what you can write down is a query like this. So you can say merge into my table using the data that you want to upsert. You can specify a join condition, and when it's matched, you update the data. And when it's not matched, you insert the data. I might have gone over that a bit quickly, but this is basically that I wanted to show you. Are there some more questions in the last few minutes?
I have one question, Bram, related to what Andras has asked before. And it's still not clear to me, like, is this Delta format still valid Parquet format? Like, if you try to read this as a normal Parquet file, it will fail, or you will just get the Parquet data, but without all of the Delta metadata?
No, so if you would read it as Parquet, that in that sense would it might work, but you will get inaccurate results, because what Delta does is it will keep tracking the transaction log, what Parquet files are part of a particular version of the table. If you would ignore the Delta log, you would just read all the files in your data lake. And that might not give you that will most likely not give you the correct result. Though what you can do, if you want to go back from a Delta table to a Parquet table, it's actually quite simple. You take the last version of the table, you delete all the other versions of the table. So in Delta, there is this command called vacuum that you can use to remove all the old versions of the data. So basically, all the Parquet files that are not referenced from the Delta log are deleted, and you only stick with the files that are being referenced in the latest version of your table. And then after you've done that, you delete the Delta log table, and you're back to your Parquet table.
Okay.
So that would be the process for that.
Thank you.
Yeah. Any more questions? Happy to answer anything.
And is there any way to also to limit like the history? Is that configurable? Because I guess that this will also increase quite a lot the size required for each table, right?
Yeah, that's correct. So there are some properties that you can configure. So with this vacuum command, you can basically delete older versions of the table as well. I think it's configured by default for 30 days. So any data, you can keep any data for 30 days, and after that it will be deleted, but this threshold is configurable. For example, if you're very cost conscious and you do not really want to keep a long track of versions of your table, you can change that parameter to run it more regularly.
Cool, thank you.
Hey, Bram. Yes, I have a question, maybe two. Hey, Bram. So you have like the transaction log, does it store the differences or does it store the entire new file? Kind of like a duplicate.
So it stores the differences on a file level. So if I would write multiple files, so suppose I have a table and then I update on that table, and an update means some old Parquet files might get marked as deleted and a few new Parquet files got added, and then I have the other Parquet files from my previous version that weren't affected, they're also included. So basically in this log, you will find which files were affected in this version. And that way, if you would go back to a previous version, you would be able to figure out the delta between the two. It does not do it on a record level. So you would still have to do then a comparison on a record level, what changed between version 2 and version 1.
Okay, so there's a bit of a disk space wastage there, right? If let's say one file is only changed by 1 byte, then it's a wastage.
Then in theory, that would be a new file. That's correct. Yeah.
Okay, that's fine. But what is the performance cost? Let's say I have 1 million files. Maybe I partition it a bit excessively, and I have 1 million files. Would that mean that Delta is going to make hash comparisons on 1 million files?
No, so it's like, so suppose you would have 1 million files and I would update one record in those files. Then what would happen in your transaction log is one of those files will get marked as removed and a new file will get added with the records from that file and then the record that you wanted to update, something like that. And all the other files still like remain there. It's not that it's going to rewrite 1 million files. That would only happen if in every file, in every of those 1 million files, I'm going to update something. So that's the worst case scenario.
Okay. Okay, sounds good. Thanks, Bram.
Yeah, I hope you learned something. I think I saw also that Gabor asked the question. Oh, sorry. Go ahead.
Oh, yes, thank you. Yeah, I was wondering, like, I suppose that you can select some point of the history of the data, right? Like, I want to go back in time to this point in the data, and I was wondering how is that possible, and if you can like give meaningful names, like versioning, basically to past versions of the data or something like that.
Yeah, maybe that would be a cool feature. I don't think you can name a particular version that way. There is an optional, I would have to check that myself how that works, but there is an optional metadata column that you can use for these kind of things. So I guess technically, if you would build a pipeline, you could provide that kind of metadata when you make an update to a table, if you want to give it a particular name. Sorry, what was your first question again?
If how to go back in time, basically, like I want to select the version of the data 1 month ago or 1 week ago or something like that.
Okay, so in this Delta log just contains references to Parquet files. And even if you, for example, if I would delete a few records and then go in my transaction log, I would see that a file got deleted or multiple files got deleted. And that's marked in the transaction log. If I would physically look up in my data lake, then I would still see those files. So that's the reason if I go back to a previous version, I would go to my previous version in my Delta log, I would still see those files listed and I could look in their contents. This will only not hold true if you run this vacuum command. So this vacuum command really deletes this data from your data lake. And then if I would go back to that previous version, it would not be able to find all the files associated to that version.
Okay.
So that's also the trade-off in this case for how long do you want to keep track of that history. I've seen customers that want to keep track of all the history. I also have seen customers that just do it for a few weeks because they just want to make sure that if something went wrong that they can jump back. And then if the data is like, if the history is older than 2 weeks, that's what they delete.
Okay, perfect. That makes sense. Thank you very much.
And then Gabor asked, is the data lake a good concept if you do not have large unstructured data, just structured transaction tables, but you face a lot of backlogs, missing days on hours that will be input with delays, or is it in this case better to use the data warehousing approach? So I'm actually of the opinion that you can also perfectly do this on your data lake. Nowadays it supports like a lot of the features that you also have in your data warehouses. What I've seen is if you have like a use case where you really have like thousands of users, then it will become quite tough to, like, at least in performance wise, to get a comparable performance with regards to like these specialized data warehouses. If the number of users is lower, we've now seen with how we've implemented it at Databricks, if you have a Delta lake and you make use of the Delta engine, that we really get a very competitive performance with regards to data warehouses, which is actually quite cool, because if you think of it, your data is like, you don't store it in someone like in this in a data warehouse in this proprietary format. You own your data. It's in a data lake. You have now separated compute and storage. So if I do not have to compute anything, I just turn my clusters down. That doesn't cost me any money. And if my SQL analysts they want to work with my structured data, we spin up a cluster and they can directly query that data. So yeah, I think data lakes really start to become a good alternative to that as well.
To get. So of course, maybe in the next 10 minutes, you also can ask several questions, both from Bram and from me. But maybe that would be also nice if you could, again, just open this link and vote that, how did you like it? I mean, how did you like this session? And also, of course, if you have any questions related to these presentations or the data lakes or for this normal data warehousing, then yes, feel free to ask. And also we will share this video and the presentation itself.
May I ask also one last question, Martin?
Sure.
For the Lynx Guide team, when is Lynx Guide going to support Spark 3.0?
that's maybe better if the Lynx Guy team is answering.
Yeah.
Yeah, we are here.
Sorry, just struggling to unmute. When are you sending the pull request, Bram?
Yeah, I'm waiting for you guys.
Oh,
but that would be really awesome.
And,
yeah.
How compatible is it? Do you think it's a 1 day job to upgrade, or 1 week, 1 month?
What I think that's probably the challenge is the Scala upgrade that comes with Spark 3. So
right.
So that will probably introduce most of the, I don't know like how many packages you have that like already have migrated to the new Scala version.
All right, I think I looked at this, and we would need to upgrade Play framework as well. We really want to upgrade these things, and it would be awesome to use Scala 2.12, but yeah, just have to find the time for it.
We are targeting for the course now.
Okay, that was my question. Thanks.
Yeah, thanks, Bram. That was really good. It was also good to see you. So thank you for joining us for this.
Yeah, thank you for having me.
Yeah, so thanks a lot for the presentation. As we can see, the NPS is positive that we get. So that's, I'm happy to see. And then in the future, we are trying to organize more and more events like this, which will be open for a wider audience. And yeah, so thank you very much, Bram, for the presentation, and also for everybody for participating. And yeah, if you have some questions, then feel free to ask. But if it's not, then have a nice weekend or a nice Friday for those who joined from Europe.
Yeah, have a nice weekend.
Enjoy. Bye.
Thank you, guys. Have a nice weekend, you too.
Bye-bye.
Thank you, Bram, for coming.
Thanks, Bram.
Thank you. Bye-bye.